The derivation sheet serves as a comprehensive guide to understanding how physical interactions, such as those involving magnetic forces or mechanical torque, are governed by the geometric relationship between two vectors. By bridging the gap between raw spatial data and the resulting physical effects, the sheet provides a clear logical path for why these forces behave the way they do. The state diagram within the derivation sheet captures the dynamic life cycle of these physical interactions. It begins at an initial state where two primary vectors are established, such as the velocity of a particle and a magnetic field. The diagram then tracks the parallel state, where the vectors point in the same direction, resulting in no force or interaction. As one vector rotates, the system enters a rotating state, where the intensity of the interaction builds until it reaches the perpendicular state. At this peak, the interaction is at its maximum intensity before diminishing as it moves toward the anti-parallel state, where the effect returns to zero. This visual map illustrates that the strength of these physical phenomena is entirely dependent on the angle of interaction. Complementing this, the sequence diagram outlines the step-by-step logical progression required to prove these physical behaviors mathematically. The process starts by breaking the vectors down into their basic spatial components. It then follows a sequence where these components are combined and squared to determine a total magnitude for the interaction. A crucial stage in the sequence is the use of an elegant bridge, known as an algebraic identity, which allows the logic to shift from abstract components to actual geometric properties. By applying fundamental principles of geometry, the sequence concludes by successfully isolating the specific trigonometric relationship that defines the angle between the vectors. Together, these two diagrams illustrate that whether one is observing the twisting force of a lever or the deflection of a charged particle in a field, the underlying logic remains a consistent journey from spatial orientation to a final physical result.